is a world so dangerous, so impossible, no one has ever attempted to explore it. It's not in space, not on Earth, but deep inside. We think we walk on solid ground, but traveling deep inside of our planet, we will discover another world. Filled with bizarre creatures that live only underground, we'll see gold formed before our eyes. Filled 120 degrees heat inside a volcano, discover diamonds buried 240 kilometers down, and giant tornadoes of liquid iron. Until over 6,000 kilometers down at the center of the Earth, we reach its beating.
The short clip that you have watched earlier is just a peek of refreshments and learnings has our group to offer.
But before diving into that,
let us first introduce ourselves as we are one in formulating this output and discussions.
hi, I am Vic Regine Torres Iliran.
I am Giselle Deloria.
I am Arya Galingan.
I am Jonathan Mijaos.
And I am Claire Alatraca.
We are the Group 6, and this is the Geology and Non-Renewable Mineral Resources.
What is geology and non-renewable resources? Geology is the science that studies the Earth's physical structure and substances, the history of rocks, and the processes that act on them in the most economic way to use world's resources. Non-renewable resources are any resources that do not form or replenish in a period of time. The most common non-renewable mineral resources include fossil fuels like oil, coal, natural gas, earth minerals, and metal ores like gold, silver, and iron are also considered to be non-renewable mineral resources.
As the primitive Earth cooled over eons, its interior separated into three major concentric zones: the core, the mantle, and the crust. First core is the innermost zone. It is extremely hot and has a solid inner part, surrounded by a thick layer of molten rock and semi-solid material. The Earth's interior consists of several different layers. One is the inner core, which is believed to be solid iron and which is very hot. Number two, the outer core, which is believed to be consist of rocky material, so hot and under great pressure that it is in a liquid state. Second is mantle. It is a zone made mostly of solid rock that can be soft and pliable and very hot temperature. It is a thick zone that is surrounded the core. Above this is the outermost layer of the Earth, the crust. The crust is the outermost and thinnest zone of solid material. It consists of continental crust, which underlies the continents, and oceanic crust, which underlies the ocean basin. The crust in the solid outer portion of the mantle form the Earth's outer shell, referred to us as lithosphere.
We tend to think of the Earth's crust, mantle, and core as fairly static. In reality, convection cells or currents move large volumes of rock and heat in loops within the mantle like gigantic conveyor belts. We will be discussing about the Earth's tectonic plates. Crust. It is covered by vegetation in the oceans, but if you could drain the Earth's oceans and strip away planet's vegetation, the Earth might look into something like this. Now we can see the Earth's outer shell, and if you look closely, you can also see that the shell is cracked. The red glowing lines mark the places where the Earth's shell is cracked into tectonic plates. Each plate carries a continent or an ocean basin, or sometimes both. The plates are moving in an average rate of 1 to 2 inches a year in a variety of directions, carrying continents and ocean basins with them. Here's the reason why the plates are moving. The scientists believe that the material in the mantle is circulating. The movement may be caused by heat within the mantle. As mantle material moves, perhaps only inches a year, it causes the plate above it to move as well. In some places, plates are moving in an opposite direction. They are moving apart. The area where two plates are moving apart is called the divergent boundary. In other places, plates are colliding. The area where two plates are colliding is called the convergent boundary. In other places, plates slide past each other. This area is called the transform boundary.
There were consequences as the plate moves. This leads to volcanic eruptions, earthquakes, and tsunami. Volcanic eruption is the internal pressure of a volcano is high enough to cause lava, ash, and gases to be ejected into the atmosphere. This can be extremely destructive, causing loss of life and obliterating ecosystem and human community. However, it also be benefits for it can result into the formation of majestic mountains and lakes, and the withering of lava contributes to fertile soils. Second, earthquake is one of the nature's most powerful events that caused by sudden tectonic movements in the Earth's crust. A major earthquake is a very large rock and rolled geological event. The largest recorded earthquake occurred in Chile on May 22, 1960, and 1,600 homes destroyed where 184 people died or missing. Third is tsunami. Tsunami, often called as tidal waves, is a series or large wave generated when part of the ocean floor suddenly rises or drops. The largest recorded of lost life occurred in December 2003 when the Great Underwater Earthquake in the Indian Ocean with magnitude of 9.15 caused areas of Indonesia, Thailand, Sri Lanka, South India, and even Eastern Africa.
The Earth's crust consists mostly of rocks and minerals. A mineral is an element or inorganic compound that occurs naturally in the Earth's crust as a crystalline, solid, or one that has a regularly repeating internal arrangement of its atoms. Mineral resource is a concentration of one or more minerals on Earth's crust that we can extract and process into raw materials and useful product at an affordable cost. Rock. Rock is a solid combination of one or more minerals found in the Earth's crust. Based on the way it forms, rocks is placed in three broad classes: sedimentary, igneous, and metamorphic rock. Igneous rock, like this piece of granite. Igneous means fire. This granite was created in a firing place perhaps long, long ago, billions of years in the past when Earth was new. There were no rocks. Earth was a burning hot gibel of melted minerals and metals called magma. Eventually, as heat drifted into space, Earth's surface cooled because of rock formed over it like ice over like in winter. This gas, made in minerals and metals, cooled from red-hot magma, was igneous rock. Igneous rock is not only some of our oldest rock, it is also some of our newest. Earth has never stopped making it. Somewhere, people probably watch it warm right now at the edge of volcanoes. Lava is magma from a volcano. It hardens into igneous rock. Igneous rock occurs in many forms. They vary according to kind of minerals and metals made of how fast they cool. Granite and coal slowly underground over 1,000 years. Sedimentary rocks. Sedimentary rocks develop through a long process to start with weathering and ends with lithification. Weathering breaks down rock on Earth's surface to mechanical, chemical, and biological forces. In mechanical weathering, heat, cold, ice, wind-blown sand, and faults slowly cracks and wear. In chemical weathering, rock dissolves in rain, water, which is slightly acid. In biological weathering, plants' roots both crack and dissolve rocks. Over time, even huge mountains weather bit by bit into sand, dust, clay, and minerals dissolving in water and disappear. 200 million years ago, the Appalachian Mountains were several times the present height. Where did the mountains go? They get carried away through erosion, wind, and special water moves each bit of mountain rock downhill. Eventually, eroded rocks fill up nearby valleys or get carried away in a river up to the sea. We call the move material sediments. Either way, what was once sand, mud, or gravel becomes a sedimentary rock depending on how it formed. Metamorphic rock. Metamorphic means change. Metamorphic rock is start as igneous, sedimentary, or even another metamorphic rock, but then, somewhere deep underground, get changed by heat and pressure. For instance, limestone metamorphoses into marble, granite metamorphoses into gneiss.
Rock cycle. After knowing what the types rocks are, we will be discussing the interaction of physical and chemical processes that change rocks from one type to another is called a rock cycle. Rocks are cycled over millions of years by three processes: erosions, melting, and metamorphisms. Igneous rocks can be broken down to weathering. The pieces can form sedimentary rocks. Igneous rocks can also change into metamorphic rocks when exposed to heat and pressure that change them but don't melt them completely. If exposed to high enough heat, they cannot back into magma to form new igneous rocks. Sedimentary rocks can break down through weathering from new sedimentary rocks. They can also be transformed into metamorphic rocks through the action of heat and pressure. If they get hot enough, they can melt into magma to form igneous rocks. Metamorphic rocks can break down to form sedimentary rocks. They can also be converted into different metamorphic rocks when exposed to heat and pressure, like igneous rocks and sedimentary rocks. Metamorphic rocks can melt into magma to form igneous rocks. As you can see, the interaction between the three main rock types can take several different types, and any rocks can turn into another type of rock with the right conditions.
Metallic minerals. Metallic minerals are made single elements such as aluminum, gold, steel, and copper. Non-metallic minerals are made of non-metallic elements and compounds such as sand, gravel, and limestone. Aluminum. Aluminum is used for structural material in beverage can, motor vehicles, aircraft, and buildings. Copper. Copper is a good conductor of electricity, is used to make electrical and communication wiring. Gold. Gold is component of electrical equipment, jewelry, coins, and medical implants. Sand. Sand is used to make glass, bricks, and concrete for construction of roads and buildings. We have never completely run out of non-renewable mineral resources. But a mineral becomes economically depleted when it costs more than it is worth to find. If people continue to abuse natural resources, there will be a great depletion of resources or shortage of resources.
Environmental effects of non-renewable mineral resources. Every metal product has a life cycle. For instance, a life cycle of a car. At first, the mining company will mine the mineral to extract the metal ore and separate it from the waste materials. Afterwards, it will be processed to smelting, melting, and finally converting it into a new car. Years after the car will be discarded, it will be recycled and undergo again to the process of smelting, melting, and then creating a new product. While enjoying the new products, we didn't even realize that each process makes use a large amount of energy and water that results in pollution and waste. There are several mining techniques that are used to renew mineral deposits. Surface mining. This carried away the vegetation, soil, and rock overlaying the shallow mineral deposit to remove it. It can extract about 90% non-fuel mineral resources and 60% of the coal. There are three types of surface mining: open pit mining, strip mining, and mountaintop removal. Underground mining. It involves digging down into the earth and creating tunnels and shafts that reach the deposit of resources. Placer mining. It is generally done in riverbeds, sands, and other sedimentary environments and involves shifting valuable materials from sediment to extract gold, gemstones, platinum, and other materials. In situ mining, also referred to as solution mining, that involves pumping chemicals underground to dissolve resource containing ore and the pumping it back to the surface. Extracting mineral from the earth crust and converting them to the useful products can restore to the land. Arid soil produce a large amount of the solid waste and pollute the air, water, and soil.
According to the U.S. Environmental Protection Agency, or EPA, mining has polluted mountain streams in about 40% of the western watersheds in the United States, and it accounts for 50% of all the country's emissions of toxic chemicals into the atmosphere. Nanotechnology, or tiny tech, uses science and engineering to manipulate and create materials out of atoms and molecules at the ultra-small scale of less than 100 nanometers. Nanomaterials are used in more than 1,300 consumer products, and number is growing rapidly. Sustainable use of non-renewable minerals. Some analysts point out the possibilities of finding substitutes for crushed minerals through nanotechnology as well as to the other emerging technologies. For example, fiber optic glass cables that transmit causes of light are placing copper and aluminum wires in telephone cables. And nanowires may eventually replace fiber optic glass cables. We can use non-renewable minerals more sustainably in different ways. First, reuse or recycle metal products. Second, redesign manufacturing processes. Third, reduce mining subsidies. Last, increase subsidies for reuse, recycling, and finding substitutes. For example, recycling aluminum beverage cans and extract aluminum produces 95% less air pollution, 95% less water pollution, and uses 95% less energy.
Recently, we've been experiencing worse calamities, both natural and man-made, and probably for the next 3 to 5 years, we will be experiencing worse.
We, the human beings, have caused this, so we can also solve such destruction we created.
We cannot change the past, but we can definitely change the future.
Because we, as individuals, matter.
These Earth's major geological hazards can make stop. However, we must always bear in our minds
That awareness,
Preparedness,
Reduction,
and warning systems can reduce or mitigate destructive impacts of these hazards in our community.
thanks for watching!